Welcome back to Allen High School Pre-AP Chemistry, and we're talking about models of atomic structure. Now we're going to do another orbital diagram, and then we're going to move back to the periodic table. You've done your inquiry, so I think we're going to be able to tie it all together after these videos. It's been a little frustrating, but I know you can pull it together. Now, instead of the sulfur example on 513, I want to do telluride instead, because I think it'll give us a better idea of the buildup that we're going to be doing and how the energy gets a little mixed up with our D's. So remember, I promised you, and it's coming very, very quickly, the periodic table will give us the order of these. Now, telluride has, if you look it up, 52 electrons. So we have to fit 52 electrons into this, and we're going to start very quickly with the Aufbau principle that says start with the lowest energy. Pauli says spins opposite, so no two electrons have the same four quantum numbers. Aufbau, go to the next highest energy. Pauli, spins opposite, don't want those same four electrons. Hund's rule. Remember Hund's rule says if you're in a sublevel, so we're in the P sublevel, we're going to go spins unpaired before we pair. That minimizes electron-electron repulsion. Aufbau, go to the next highest energy. Pauli, spins opposite. Hund, spins unpaired before we pair them. So we're still nowhere near 52. So we're going to keep moving along in this direction. Aufbau. Oh, this is where it gets confusing. You would think it would go to the 3D, but the energy gets a little mixed up. The distance doesn't, but energy does. So we do 4s and then we do 3D. Hund's rule says to put them in unpaired before we pair them. And then Pauli says put them spin opposite, so no two electrons have the same four quantum numbers. Aufbau, next highest, we're at the 4p. Hund, spins unpaired within a sublevel before we pair them. I may actually run out of electrons here. There we go. Aufbau says go to the next highest energy level. Hund says do unpaired before, whoops, I messed that one up, unpaired before we pair them. Okay, so now I've kind of run out, so I'm going to borrow some from the bottom. I know you see that those are full. So unpaired before I pair. And then when I pair, Pauli says go spins opposite. Okay, now I know I'm going to borrow a few more from the bottom, and normally we wouldn't do that, but I don't want to start the video over. And so telluride is going to have 1, 2, 3, and then it adds a fourth unpaired. Okay, so that's what telluride would be, assuming I hadn't stole all those electrons. Let's write the electron configuration for telluride. Be 1s, energy level 1, sublevel S, originally had 2 electrons in it. Then we went to 2s, so it's 2s with 2 electrons, energy level 2, sublevel S. Then we went to 2p, and it had 6 electrons, right? 6. And then we went to 3s, 2, energy level 3, sublevel S, 2 electrons, 3p6, 4s2, 3d10, 5s2, 4d10. Now, and finally we ended up at 5p6, or excuse me, 5p, not 6, but there were only 4. 5p4. Now let's talk about a few things here as we're looking at this. And I'm going to wrap in a whole bunch of concepts so you won't have to watch as many videos. So let's first talk about our outermost electrons, have the highest N value. Remember, distance stays true. So those would be our 5s2, and not the 4d, we'd go up to the 5p4. Now the outer S and P, if it's S and P that's outer, our outer S and P are called valence electrons. So I want you to make sure you're writing this down. This is going to be good reference. Now, your highest energy, that's point 1. Point 2 is our highest energy, is the last sublevel filling. So you find the last sublevel you are filling. Sometimes it's going to be the same as the outermost, and sometimes it won't. In this case, the last we were filling was that 5p. So those 5p4 are our highest energy electrons. So that's one term. Now, the third point I want to make is about ions. Now, the goal in ions that we're going to be dealing with in the main group are nonmetals will gain. So nonmetals are winners, and they'll gain until they reach the noble gas, the nearest noble gas. So if you notice here, if tellurium gained just 2 electrons, okay, that would make it Te2 negative because it gained 2 electrons, and it would have 52 protons and 54 electrons, okay? And that makes it a negative ion or anion. And if you'll notice, it now has a noble gas configuration. All of the noble gases end in that electron configuration, end in 5p6. Okay? So that's those are some of the points that we wanted to make here. Now, after this was your inquiry. You've already done that in class. And so what we want to do in the next part is begin to learn to walk through the periodic table in order to fill our electron configurations. So you don't have to memorize this order. We're going to look at now a summary of how the periodic table gives us that. So come back to the next video, and until then, this is signing off.